Capstone, Time Series Forecasting Project. Welcome to your first real-world Python Time Series project. In this lesson, we will predict future shampoo sales using real data. We will cover data loading, visualization, splitting data for training and testing, building a simple prediction model, and finally making our forecast. You will get hands-on experience and walk away with a solid foundation in time series analysis. Let us get started. Running the cell now. What kind of things would you want to predict with time series data? Let us start by hiding warnings so our notebook stays readable. We bring in the warnings filter. This line stops warnings from filling up our output. Running the cell now. Try running the cell and notice how there are no warning pop-ups. Step 1. Let us load our shampoo sales dataset. We will use a real dataset of monthly shampoo sales, a classic example for forecasting. We will use the pandas library to read the data. Look for patterns as we go. Running the cell now. Let us load the shampoo sales data from the web. This comment marks where we set up our data. We bring in the pandas library, which is great for working with tables of data. Here is the web address where our shampoo sales data lives. We use pandas to read the CSV file from the web and put it into a table. Now we print the shape. This shows how many rows and columns we have. This printout gives us the first few rows, so we get a feeling for the data. Running the cell now. Can you spot which column in the table shows the sales amount? It is much easier to spot trends and patterns by looking at a chart. We say this is where we make a quick chart. We import a tool for making charts. This sets up the size of the chart. We plot the sales as a line so we can see how they change over time. This gives our chart a title. This labels the horizontal axis with the month. This labels the vertical axis with the sales. Finally, we tell the notebook to draw the chart. Running the cell now. Do you notice any trends or jumps in the sales over time? Step 2. Time Series Basics. In time series data, we look for patterns based on how things change with time. We will check for trends, repeating cycles, and randomness. Let us look at some numbers up close. Running the cell now. Sometimes it helps to see just the recent data, especially for forecasting. This section looks at only the newest 12 months. We print the last 12 rows to see the freshest sales numbers. Running the cell now. Can you spot if sales go up, down, or do something else in the last year? To use dates for time series, we need to make sure pandas understands this month column. The comment says we want to turn month into date time objects. We tell pandas how to read the month information and turn it into a date. This line puts month as the main index. This makes working with time steps easier. Running the cell now. Notice how the dates are now easier to work with. Try printing data.index if you are curious. When we forecast, we train on one part of the data and test on the future part. The comment reminds us we are splitting the data for training and testing. We choose to use all but the last 12 months for training. This line takes the earlier months as our training set. This line saves the last 12 months as our test set. We print the number of months in the training set. And here we show the test set size. Running the cell now. Why do you think we do not just test on the same data we train on? Let us draw a clear line between past and future so we see what we are working with. This comment signals we are making a chart about the split. We set the size of the chart. We draw the line for the training data in one color. We draw the line for the test data in another color. This title reminds us what the plot is showing. We add a label for the horizontal axis. We add a label for the vertical axis. A legend helps us know which line means which set. We show the plot. Running the cell now. Try to predict which part belongs to train and which part is for testing in the chart. Step 3. Building a baseline model. A baseline model is a simple prediction, often just repeating the last known value. Let us see how well repeating last month's sales works. Running the cell now. A baseline is an easy guess. We just use the most recent known sales for all future steps. This comment tells us we are making a basic forecast. Here we grab the sales from the last training month. We create a list that repeats it for every test month. Printing the baseline forecast tells us what our simple model predicts. Running the cell now. How close do you think this method gets to the real sales numbers? Try to estimate. Now we will compare what was predicted and what actually happened. This line starts by copying the real test set. We add a new column, prediction, filled with our forecasted values. Now, printing both columns, we see actual sales side by side with the baseline predictions. Running the cell now. Is the prediction ever exactly correct? Where is it way off? Step 4. Model evaluation. To judge our forecast, we can measure how far off our predictions are from the real numbers. A common measure is mean absolute error, MAE, the average of how much we miss by ignoring direction. Running the cell now. Let us find out, on average, how far off our simple method is. We say we are calculating the mean absolute error. We subtract the prediction from actual sales, take the absolute value, and average it. Now, we print out our MAE result. Lower is better. Running the cell now. Try changing last underscore value to another recent month. Does the MAE get better or worse? Charts help us see at a glance where the forecast is good or bad. This section shows us prediction and real values on a chart. We set up our plot size. We plot the real test sales. We plot the predictions. The legend tells us which line is which. A title helps us remember what the chart shows. We add a label for the horizontal axis. We add a label for the vertical axis. Now we display the plot. Running the cell now. Where are the prediction and real values closest? Which month has the biggest gap? Step 5. Getting fancier, simple moving average. We can improve forecasts using recent data. A simple moving average uses the mean of the last few months to guess the next one. Let us use the average of the last 3 months. Running the cell now. Now we try a smarter approach, using the average sales of the last 3 months. The comment explains we are making a moving average forecast. Here, we set our window size to 3 months. We take the mean of the last 3 sales months. This gives a forecast that repeats the average for the length of our test set. We save these predictions to a new column, called MA_prediction. Printing our result lets us compare real sales, simple, and better baseline all together. Running the cell now. Is 3 months a good window, or would you try something else? Let us see if our moving average guess actually improves our score. The comment is about calculating MAE for the moving average model. We compute the MAE for our new method in the same way as before. We print the moving average MAE to compare it to our first method. Running the cell now. If the MAE is lower, the moving average is a better predictor for this data. Step 6. Let us try your own forecast. It is your turn. Enter a number to use as your forecast for all test months. See if you can beat the moving average. Running the cell now. Now you get to be the forecaster. Type in your own sales guess and see how close you can get. This should tell you it is your turn to try forecasting. We ask for your forecast as a number and turn it into a float. We make a new prediction column in the results table with your number. Calculate the MAE between your guess and the true sales. Now, print the score for your forecast so you can see how you did. Running the cell now. Try a few different numbers and see which is the best. Step 7. Wrapping up. Congratulations! You just learned how to build, test, and measure simple forecasts on real-world data. We loaded data, made simple predictions, and checked results with numbers and charts. There is a whole world of more advanced methods to learn in time series forecasting. Your journey has just begun. Running the cell now. For extra practice, try using a different window size for your moving average. Thank you for joining the project. If you enjoyed this lesson, like and subscribe on YouTube for more beginner-friendly Python projects. Share your results in the comments. What was your best MAE score? See you in the next lesson. Running the cell now. Would you like to try another real-world project next time?